Hello. Today we're going to be looking at random variables. So this is just the basics and it's going to be taught by me. I just done my module for random variables last semester and I want to teach you what I've learned. So let's look at random variables. But before that we need to look at probability. So probability, I'm sure you've come across probability before. If you roll a die, if you toss a coin, all of these are random events you can get from them. So there's probability to them. For each of the outcomes there's a different probability. So like if you roll a dice, we know that when you roll a dice, you get 6 outcomes. So the sample space, we call that a sample space, S, and the sample space is 1, 2, 3, 4, 5, and 6. So these are the outcomes that you can get when you roll a dice. So now this is called a sample space. We also need to know another key term which is called event. So let's look at an event. So we can have different events. So you can have like event 1, event 2, so event 3. What is an event? Well, you can make it up yourself. So you can have like the first event. You can say if I get an even number, so if my outcome is even, you can have another outcome is odd. Or you could have the outcome is a 6. So when you roll the dice, you get a 6. So these are the 3 outcomes. So now these outcomes, we can have that if you can model these outcomes in a graph as well. So let's say this is our sample space, okay, S, and we have these outcomes 1, 2, 3, 4, 5, and 6. So we can have that the even numbers are these. Let's call the event 1. No, let's call that should be event 2. And let's call this outcome event 1 when you get even numbers. Also, you have another outcome that we talked about was a 3 when you get a 6. So this is another way of representing your sample space, and this is for a dice. Now let's look at some key terms that we're going to be using a lot. The first one is union. So union. So you have union, you have intersection, you have mutual exclusive. All these words we're going to be talking about. So union, what is that? Well, that is like the probability that A, let's say event A, is union to B. So what does that mean? That means that A and B, okay? A and B. So A or B, sorry. A or B. So the probability that we get A or B, let me just write probability of A or B. So for this one, if we say that what's the probability that we get A1 union A2? What is the union of A1 and A2? Well, what's the probability of getting an A1 and A2? So it's OR. OR is very important. You need to remember OR is even or odd. So when you roll the dice, we know we can either get a even or odd. So we will get an A1 or A2. So that is 1. That's the probability that A1 or A2 are happening. So that is 1. And we can have another one, probability that you get a event A1 A2 or A3. What is that probability of getting A2? A2 is odd, event odd, or A3, which is probability of getting a 6. So that is a half. So because getting an odd number probably is half, or so you use a plus for or, getting the outcome of 6. So to get a 6, when you roll the dice, we know it's 1 out of 6. And if you add these together, that's 4 out of 6, which is 2 out of 3. So that is union. I hope you understood that. Now let's look at another one, intersection. So this one's fairly easy to understand, but I'm just going to tell you how we represent it. So intersection is A, but it's upside down U this time. So it's A intersection with B. So that means intersection is like A and B. So both of them at the same time. So you can have a probability of A and B. Okay, so let's use this as an example. So probability that you get A1 intersect with A2. So the outcome is even and the outcome is odd. Is that possible? No, it's not. So that would be a 0. Let's do another one. Let's do A1 intersect with A3. So we know A1 is even, and we know A3, that's outcome is odd. So we look at this graph, it'll help us. So A1, right, is this one, and then A3, it is intersecting. Which one is only intersecting? Is 6. So 6, if you roll a dice, so what happens is if you get an even number, then you also have a chance of also getting a 6 as well. And what is that probability? That's 1 out of 6. So it's very small because when you roll a dice, you can get an even number and you can get also the outcome 6. So that is 1 out of 6. It's not half plus 6, or it's not like half times 1 out of 6. Okay, so that is intersection. We have another event. Let me just write it here if you can see that. So this one is a disjoint or mutually exclusive. So I'm just going to talk about it. I'm not going to write it down. This is when two events, they don't occur at the same time. So we know that event A2 and A3, they don't occur at the same time. And that is what mutually exclusive is. We also have independent, when one event is not affected by another event. So if one event takes place, and that is not going to affect another event taking place. Okay, so now this was the basics of probability. Now we're going to look at some more probability. So let's look at, there are some okay, so let's look at joint and marginal and also conditional probabilities. I'm sure you've heard of those. So now joint probability. So you have a joint, it's in the name. Okay, joint probability. So I have my notes here, so I know I don't lose track. So it's when probability A, I, and B, J. So this is probability that event AI and BJ are happening at the same time. So this is so they're happening simultaneously. You can also write it as before we looked at intersection. It's the same one, but we write it just together because it's and. When it's and, we know that it's AI and BJ. It's the same as intersection. So it's when the AI and the BJ are happening at the same time. So these are the two events, AI and BJ. So AI is like A1, A2, A3, A4, and BJ is B1, B2, B3, B4. Okay, so that's joint probability. Now marginal probability. So marginal probability, and you have to look at the events by themselves. So like, because AI and BJ, okay, they happen at the same time. What about if we just want probability of BJ, so a specific BJ, okay? And we can work that out using this joint probability. You have to just take the sum. So it's from I1 to N. N is like how many there are. So let's just write small n. And then you just write BI, okay? It's not J, it's I. So BI and then BJ. So BJ, it could be any of them. Like let's say if probability of B1, okay, it's the first B1 event B1. So you can take the sum from I equals 1 to N, and then this is AI, and then this one would be B1. Okay, so it will be B1. So because we set the J to 1, so there will be the J will change to a 1. Now we can do the sum. So it's from A1 B1 plus A2, because we're doing a sum from 1 to N, to B1. B always stays the same. B is always B1. We can do all the way to AN to B1. If you add this all together, we will get B1, probability of B1. So that is marginal probability. We can take out the B1. We can do A1 plus A2 plus comma comma plus Bn, adding all of, okay, sorry, this is a probability, okay, sorry, my fault, I forgot to write the probability. So your probability of A1 B1 plus probability of A2 plus B2, and then when it's a OR, you can take them out as well. Probability of, okay, so yeah, what was I saying? So we can write this as probability of A1 B1 plus probability of A2 B1 plus dot dot plus probability of an b1. Here the probability of b1 always stays the same, and a1 a2, then that is the only one that's changing. Okay, so I hope you understand marginal probability. You'll have to just use this formula because it's very helpful, and maybe you might be given this data in a graph. So you might have on the first column, you might have all the A's. So you have A1, A2, dot 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 AN. And then on the first row, you might have the B's. So B1, B2, dot 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 BN. So we want the marginal of probability of B1. So that is this column. So we want only this bit. Okay, we have to add them all together. Add all these, we have to add. Okay, and then we'll get our B1, and that is marginal probability. Now let's look at conditional probability. Okay, I'm not going to write all of it. So conditional probability, let me just write it to help you, maybe you can remember. It's probability of, so given that AI happened, what is the probability that BJ will happen? So some event happened already. How will that, what is the probability now that you'll get a BJ? So imagine you had a cup, okay, and inside this cup you had circles. So you had 3 circles, okay, and then you also had squares. So now I ask you, what's the probability that you'll get a circle? So let's say that x2, let's say that is a circle. Let's call this C. Given that you got at the start, you got a square. Okay, what's that probability? Well, this is the cup. How many squares are there? There's 2. And if you take 1 square out, how many are left? Only 1. Now, what is now the probability of getting a circle? So you took out a square. Now how many is remaining? 1, 2, 3, 4. 4 are remaining. Now you want to get a circle. How many are left? Well, there's 1, 2, 3. 3 circles remaining. Okay, so it's 3 out of 4. So if you take out the square, there's only 4 remaining, and out of those 4, 3 of them are circles. So that is conditional probability. So now there's a important formula that you need to, that connects all of these together, and that formula is very important. So we know the joint probability is probability that A, let's just now, we don't need to write the I's for now, A and B, the joint probability of, okay, so probability of A and B happening. The formula that you need to know is probability of A given B happened times by probability of B. This formula is very important. This is how I remember it. So we use this a lot. We use it in digital communications. We use this in many other modules. So this is the joint probability of A and B. And to work that out, you can use the conditional probability. Given that B happened, what's the probability of A times by the probability of B. There's another way you can write this. Probability of B given A happened. Now, on the outside, because A probability that A already happened, you also need to write probability of A. Okay, this formula is very important. So now there's another concept that I want you to also know, and that is Bayes' rule. Okay, Bayes' rule. It uses all of these again. So what is the formula? It's important to know these formulas and the examples. We'll do an example as well using Bayes' rule. So before that, let me just rub this out so that I have space to write it down. And then we'll have a very useful example to help us understand. Bayes' rule is very important. I've used it a lot in my studies, and there's always a question on an exam. If you do learn about Bayes' rule, there's always an exam on it. So Bayes' rule. So first, let's go over the formula. So and I'll also help you remember it as well. Probability that B took place given that A happened. And now that is now that is probability of you swap this around. So that's probability that A happened was probability of B happening. You can work that out by turning these two around, which is A given B. Now I already told you that because B already happened, you also have to write next to it. Okay, and you also need to then write what's remaining is probability of A. Okay, so this is Bayes' rule. It's just a formula. There's a very useful explanation, but I'm not going to tell you. It's very in depth, but this formula is important that you know it. So let's look at an example, and then hopefully we'll understand Bayes' rule. So let's look at a binary communication channel. B, E, okay, so you have A. Let's say A is let's say that when you transmit, you get a B. Okay, you transmit A and you get a B. Okay, what's A? A is 1 transmitted. Let's say that AC, that's 0 transmitted. Okay, so that's AC. Now B, let's say that 1 received. And BC is what? 0 received. Sometimes you are sending a 1, and what happened? Because of your channel, it might be that a 0 might be received. A channel might go through the channel, might be some noise, and then it will become a 0. Or you send a 0 and then somehow a 1 is received. So I want you to find probability that you need to find probability that a 1 was sent, right? and then a B was just. So this is the probability I want you to find. This is a conditional probability. So you received a B. So you received a 1 was received. What is the probability that you sent a 1? So that is good, right? You want to find that probability. How would you find it? Well, you'll use Bayes' formula. So you just swap these two around, then you write A, because A is here, you have to write A here, and then over probability of B. Now I've given you some key probabilities. So you already know probability of sending a 0, and that's 0.4. Probability, I'm giving you the probability that you send an A and you transmit a 1, and then a 1 was received. That is probability of 0.9. So it's a very good channel, not that bad. And I'm also going to tell you probability that you send a 0 and a 0 is received, and that is 0.95. So we've already been given some useful values. So we've been given this one. Have we been given a probability of sending a 1? Well, we've been given a probability of sending a 0. So with that we can work out probability of sending an A, and that is 0.6, because if you're sending a 1, then half of the time then you'll be sending a 0. So you can just do 1 minus 0.4, you get 0.6. Now we've been given A. Now what about probability of B? Have we been given that? No. So to work out probability of a B, that's very easy, because receiving a B, the formula is very easy. So it's a probability that you get a B given that A was sent, and you just write probability of A, plus probability that you received a B given that a 0 was transmitted, and then you write probability of AC. So this is a very useful formula. It helps you a lot, because probability of B is here. This is marginal, remember? This is marginal. So given that B, you want to find the probability that you got a B given that 0 is sent, and then you also then write this conditional, but then you also need times it by probability of A, plus now again you can get a B if a 0 was transmitted. Okay, that's another conditional, and then you need times it by probability of a 0 being transmitted, and then you can work that out. Okay, and that will give us, so plug these numbers in. We know this one. Okay, let me just do this properly. So we know this one, and we also know this, we also know that. But what about this? Do we know this? Well, not really, but we can work that out. So probability of getting a B given that AC was transmitted, AC is a 0 was transmitted, plus probability that you get a BC given that AC was transmitted. What does that add up to? Well, so probability of you sent a 0 and you got a B, that's what we want to work out, plus probability of you send a 0 and a 0 is received. So those two add up to 1. So with this formula you can work out this Okay, so this formula is, just think about it, it'll start making sense. Okay, and then now you worked on this, now you worked on p probability of receiving a 1. Now you can just plug all the numbers in and you'll work out this, which we wanted to get. Okay, so that is Bayes' rule. Okay, so let's move on now. Let's go to random variables, which our topic is about. So that was just the basics that we should all know. And this will help. This is the basic probability. Now let's look at what we what our video is about, which is random variables. So random variables, let me just tell you what it means. It might not be very useful because it might be your first time looking at this random variables, but it's good to have the definition, and then once we go through examples it will make sense to us. So random variables is a function that assigns a real number to each outcome. So you're assigning a real number to each outcome. So an outcome could be, maybe if you toss 3 coins, what are the outcomes? So it's like tossing 3 coins. Okay, so we want to assign real numbers to each of these outcomes. So let's say you're tossing 3 coins. What are the outcomes? Let's say number of heads. These outcomes we want to assign real numbers. Okay, so let's say probability, let's say x is the number of heads. So let's say this is an outcome, you're getting 0 heads. What is that probability? What is the probability of getting 1 head? Probability of getting 2 heads, and probability of getting 3 heads. These are the 4 outcomes that we want to assign a real number. So you toss a coin, and why is there are a lot of you toss a coin, you can get maybe tail, 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 you can get a head, tail, tail, or you can get a head, you can get a tail, head, tail, you can get a tail, tail, head, and so on, and then you can get a head, 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 right? So how many outcomes there are? Well, let me just tell you, there's 8 outcomes, and to get 0 heads is only tail, 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 and to get 1 head there's this one, this one, this one, which is 3 out of 8, and to get 2 heads, that is also 3 out of 8, and the remaining one, well, if you add them all together, minus it by 1, you will get 1 out of 8, and that is getting 3 heads. So this, we assigned real numbers to an outcome. So this is random variables. Now we also have another function which uses this. It's called distribution function. Okay, so I was going to go through an example, but I think this example helps us understand. So we're going to be using this information. So we know probability x equals 0, probability x equals 1, probability x equals 2, probability x equals 3. So this is all equal. Now, distribution functions. So it's the probability that capital X, all of these are capital X, is less than or equal to small x. So what is small x? And you can also write this, sorry I should have wrote that first, but I'll just write it next to it. You write this as fx big X here, and then this is small x. Okay, we write small x with a nice curly, and the capital X we write straight. Okay, so this is called cumulative function, distribution function, and this is a cumulative distribution function of the random variable x. Okay, so what does this mean? Well, this means that the probability that x is less than or equal to small x. So let's put some numbers for this small x so we can understand. Okay, let's say that probability of big X is less than or equal to small is equal to 0. So what is that? Well, that is just this one, okay? That is this probability of x equals 0, because capital X is less than or equal to 0, and that's 1 over 8. So this is cumulative distribution function. Now probability that x is less than or equal to 1. So capital X is less than or equal to 1, so it's 1 or 0. So it's that is equal to 1 over 8, this one, because it's probably x equals 0 plus x equals 1, and that's 4 over 8, which is a half. So you can do that for the rest of them. You can also do it for probability that x is less than or equal to 3. What would that be? Well, that would be 0, x 0, 0, x equals 1, x equals 2. You add them all together, x equals 3, add them, that is 1. So that is cumulative distribution. You can also graph this very easily. So x, this is capital, this is small x, this is f of x. So when it's first, let's start with 0, 1, 2, 3. So first is 1 over 8. So when it's 0, it's 1 over 8. Now when it gets to 1, it goes to a half. And then when it's then you add them something, and then it's 1. Okay, it keeps going. So that should be 1 up here. So all of this is cumulative distribution function. Now there are some probabilities that we need to, so we just graphed it. Now there's also some properties. So if you want to find the probability that is between some variable, so x is between x1 and x2, so you don't need the one here. You can just do the cumulative distribution function. You can do fx is x2 minus fx is x1. Okay, so because it's between these two, remember when we drew the graph, you can find the cumulative distribution function of x1, x2, and then minus that by x1, and then you'll find the probability between these two variables. So we know that the cumulative distribution is this: x is less than or equal to small x. Now what about the probability that x is bigger than or equal to small x? How would we work that out? Well, you can just do 1 minus fx, right? Because this equals this, and then you can just minus it, and then you get the answer. Okay, so that is random variables, and that is distribution functions. Now let's look at mean, variance, all of that, because they're also very important in probability. So describing a random variable, you can use its characteristics. There are a few characters that you need to know. You have the mean. So the mean we can write as expectation. Okay, expectation of the random variable x. We know that that is the mean. We normally write it as a mu. Okay, so that is the mean. If you want to know the formula of this, well, that is the sum. So this is the PMF, okay? So it's the probability mass function. So we're using the sum. So xi, probability that, remember this probability that x is equal to xi. This formula is very important. So this is the expectation or the mean. So let's use an example to understand this formula. So tossing a coin. If you toss a coin, what are the outcomes? Remember what random variables mean? It's a function that assigns a real number to each outcome. So let's say the outcome is a head. Assign a real number to that. Let's assign it as 0. You get head, it's a 0. And then a tail, let's assign it as a 1. Now we can work out the expectation of x. Using this formula, e of x will be equal to the sum of this. Okay, so you have xi. Let's say xi is the first one. Let's say xi, that's 0 times by the probability that x is equal to x1 plus, because we're doing the sum, now this we done I is 1, now let's do I is 2 plus 1 times by probability that x is equal to x2, which is a 1. What is that equal to? Well, probability, so 0 times probability that x is equal to 0. Oh, sorry, that shouldn't. So first one we said is a head, right? So the probability of getting a head is a half plus 1 times probability of getting a tail, that's 1. That's a half. So that is equal to a half. So if you toss a coin, you get a head sometimes, you get a tail another time, you get a head. If you do that 1,000 times, you'll get 50-50, right? So that is the mean. Now variance. So this was the mean, expectation of x. Now let's look at variance. We use the expectation of x in that as well. So we write it as v r variance of x. Well, what's the formula? Well, the formula of that is e of x squared. Okay, this was e of x, that's the mean, but this is, first you do x squared, you square it, minus the mean squared. So you take the mean and then you square it. Okay, so let's do the same example for this. You can also to work out e of x squared, we can use this formula. Okay, so e of x squared, you just need to replace some values. So I equals 1 to n. So xi, you need to replace that with a squared. Okay, and then you need to do times by probability of x equals xi. You don't need to square that, you just need to square this, and then that's how you get x squared. But you also need to put in this formula to get the variance of x. Okay, so do we have an example for this? So we can do it for this tossing a coin. Just put these values in there, x equals 0, x equals 1, then you'll get x squared. So if we do that, so because it's 0, 0 squared is nothing, 1 squared, and that's a half, right? Because this will be 1 times by probably x is equal to a tail, there will be a half, so that's 1 times a half. And then if you put that variance is a half minus the mean squared. The mean was a half, and square that, which is a quarter. So a half minus a quarter, that is equal to a quarter. That's the variance of this example. Now that is the expected value, and we also looked at variance. So let's look at another one. Let's look at let's look at correlation coefficient. What's correlation coefficient? Well, if you have two events, we want to find how are they correlated. So we'll be using the expected values and also the variance. They link together. So the formula for this is, for the correlation coefficient, is a probability, is a correlation or coefficient of x and y. If you want to work that out, you need to use the standard deviation of x and y over standard deviation of x times by the standard deviation of y. So what is standard deviation? Well, we know variance, right? Well, standard deviation is basically the square root of variance. Okay? So, and to work out the standard deviation of x and y, that is the expectation of xy minus x expectation of y times by. Okay, so to work out the standard deviation of x and y, so the joint, well, that is expectation of x and y minus expectation of x times by expectation of y. And now this one, we know we can use this formula, so that's square root variance of x times by square root of variance y. So that is the correlation coefficient. So if they are not correlated, what would the answer be? Well, it would be 0. And if they are fully correlated, it will be a -1 or a 1. So positive correlation coefficient or a negative correlation coefficient. So they are correlated, but they could be positively correlated like this, or negatively correlated like that. Okay, so no, not like that, sorry. Like that. Okay, so that's positive, that's negative. So that's correlation coefficient. Now we've looked at conditional probability. You also have conditional expected value. So we looked at expectation. Now we've looked at expectation, E of x, right? Now we're going to look at conditional expectation. So that's the expectation of x given a happening. Okay, so a happened. What's the expectation now of x? So a affects x, right? So if you roll a die, event A happened. Let's say event A is even number. So you roll a die, you get an even number. Now what's the even event A happened? What's now the expectation of x? So you can work that out. So remember the formula that we looked at? We used the sum, like sum and then xi times by probability of x equals xi. So you can use that. So you can get the outcome is a 2 because it's even number, so even number happened, times by probability that x is now 2 given that even number. So plus you get a 4, and that's probability that you get a 4 given that an even number happened, plus you get a 6 times by probability that x is 6 given that a happened. So what is a? Well, when event A happens, you know that when even number is rolled, someone tells you, like, I roll the die, I don't know what the die is, someone told me it's an even number, so I can think, okay, it could be a 2, it could be a 4, it could be a 6. So that's like the conditional expectation value, and you can put the numbers in. So 2 times, so you get an even number, and then you get, what is the probability that will be a 2? Well, that will be 1 out of 3 plus 4 times 1 out of 3 plus 6 times 1 out of 3. Add that all together, you get a 4. So that is the conditional expected value. This is the formula that you need to try to remember. So here, that is all for conditional expected value. Sorry I rushed it, but there's not much to talk about. It's just the more you practice doing examples on it, the easier it will be. Okay, now let's look at probability mass functions of random variables. Probability mass function of some random variables. So we have a lot of probability mass functions for different random variables. Some random variables, like a coin toss, the random variable is uniform and there's only 2 outcomes. Some random variables, like a die, there's 6 outcomes and they're all uniform. Some random variables, you either have a success or failure, like a coin toss, but the probability isn't a half. It could be success could be a quarter, and then failure would be 3/4. So we're going to look at a lot of random variables, some common ones. Though the first one we'll look at is the uniform PMF. So the uniform PMF, uniform probability mass function. So let's just write PMF so you remember. Uniform probability mass function. What is that? So you have like a coin toss, you have like a dice, all of them have the same probability mass function. So for a coin, so this is a formula. So it's probability that x is equal to xi. So x could be, for a coin toss, could be a 0 or it could be a 1. For a dice, it could be x is 1, x is 2, x is 3. Now we want to work out that probability. Well, this is in general. It's b minus a plus 1. So what's b, what's a? Well, for a dice, it would be 6 is the maximum minus a. Minimum is 1. 6 minus 1, which is 5, plus 1, which is 6. So for a dice, the probability mass function is the probability is 1/6, and we know that, and that's correct. So this formula is correct. So the mean, what is the mean? How do we work that out? Well, it's just the expectation of x, and we know the formula. I already told you, so I'm not going to write it. And the variance is, it's a bit different. So remember, e of x squared minus e of x squared, right? So it's the same. I wrote it down again so you remember. So that is uniform, and we also looked at an example. Now we have another one, which is binomial. No, Bernoulli. Bernoulli PMF. So we're going to stop here, but thanks for listening. I hope you find this enjoyable.